A computer's greatest strength isn't intelligence, it is patience. It will do the same thing a million times in a row, without getting bored, without making a mistake, without slowing down. The tool that unlocks this power is a loop. And once you understand it, you understand how everything from a spreadsheet to ChatGPT actually runs. Think about anything a computer does at scale. Sending 1,000 emails, processing 1,000,000 rows of data, rendering every frame of a video, checking every pixel on your screen 60 times a second. None of that is written out 1,000,000 times by hand. No programmer types the same instruction over and over. Instead, they write it once and wrap it in a loop. The loop says, do this again and again and again, until I tell you to stop. This is what lets software scale beyond a single calculation. One operation is just arithmetic. One operation wrapped in a loop, running over millions of items. That's a program doing real work. There are two kinds of loops you'll use constantly. The for loop, when you know what you're looping over, and the while loop, when you only know the condition to stop. We'll see both in code in a moment. Every loop is the same shape, a thing to repeat and a rule for when to stop. Get the stop rule wrong and the loop runs forever. You'll see that too, and how to escape it. A for loop walks through a collection, one item at a time. A list of names, a string of characters, a range of numbers. On each pass, a variable holds the current item. You do something with it, and the loop moves to the next. When the collection runs out, the loop ends, automatically. You never tell it to stop. It knows. A while loop is different. It doesn't walk through a collection. It checks a condition. Is this still true? And as long as the answer is yes, it keeps running. The moment the condition becomes false, it stops. This is for when you don't know how many times you'll loop. You only know what keeps you going. And the danger of a while loop. If the condition never becomes false, the loop never stops. An infinite loop. Your program freezes. Every programmer has done it. We'll see exactly how it happens and the one line that prevents it. Python lets you loop through almost any kind of data. The simplest case, a list of numbers. Watch what happens. Read it like English for each num in nums, and here's a word you'll hear constantly. Each time the loop runs is called an iteration. One pass through the body, one iteration. Now, here's the thing beginners get confused about. The variable num isn't the whole list. It's one item, and it changes every iteration. Watch. The loop creates num, and on every pass, it swaps in the next value. 5 values, 5 iterations. The loop ran the print statement once per item, then stopped on its own when the list ended. One thing beginners get wrong. Watch, if I print nums instead of num by mistake, like we see in this next example, see the difference? Num is one item. Nums is the whole list. The loop still ran 5 times, 5 iterations, but each time it printed everything. Small typo, completely different output. This is the kind of bug that wastes an hour of yours when you're just starting out with coding. What if you don't have a list? You just want to repeat something a certain number of times. That's what range gives you. Code these all, open range, and run it. Range 1, 6 starts at 1, stops before 6. The second number is the boundary. Python stops just before it, never at it. This strip stops everyone at first. Let's code these out, open these one, and run it again. No start number, Python begins at 0. This is why programmers count from 0. The language defaults to it everywhere. Let's add a step. Let's get rid of these. Then open the next example. Run it again. 3 numbers now. Start at 0. Stop before 11. Jump by 2. Every even number. The step is how you skip. Count backwards or stride through data. First intermediate one. Clear the terminal. A for loop runs a known number of times. But sometimes you don't know how many times. You just know the condition to keep going. That's a while loop. Let's see this in action. This line is the most important one. X plus equals 1 adds 1 to x each time. Run it. The loop checked the condition. Ran the body. Updated x. Checked again. The moment x hit 5, the condition became false and the loop stopped. Now, let me show you exactly why that line matters. I'm going to delete it. Don't run this at home unless you're ready to use Ctrl+C. We're gonna code these out. Open our infinite loop. Let's run it. Look closely. There is no line that changes x, so x stays 0 forever, which means x smaller than 5 is always true. This loop has no way to ever stop. If I ran this, it would print 0 1,000,000 times a second until I force quit it. This is an infinite loop, and the fix is always the same. Make sure something inside the loop moves you toward the stop condition. If you ever get stuck in one, Ctrl+C in the terminal breaks you out on most systems. Let's use it. Ctrl+C, clear the terminal, code these out, open these all. 2 keywords give you fine control inside any loop. Break and continue. Let me show you both. First, break. Let's use it. The loop printed 1, printed 2, then hit 3, and broke out completely. It never even looked at 4 or 5. Break means I'm done. Leave the loop now. Let's look at the continue to code these out, open these, then run it. Oops, what happened there? We coded out nums as well. Sorry guys. Save this, clear terminal, run it again. See the difference? Break stops everything. Continue skips just one iteration and keeps going. The loop printed 1, 2, skip 3, then carried on 4 and 5. Often you need both the item and its position. Beginners do this the clumsy way. Let me show you the clumsy way first. This works, but it's fragile. You have to remember to create the counter and remember to increment it. Python has a better way. Let's see that one too. Code this one out, then run it. Same output, half the code. No counter to manage, nothing to forget. Enumerate hands you the index and the value together, every iteration. This is what real Python developers use. Let's code these out, and then let's take a look at the zip example. Enumerate pairs an item with its position. Zip pairs items from two different lists. If you have two related lists and want to walk through them side by side, not nested, parallel, that's zip. Run the zip. Two separate lists, looped as pairs. No index juggling. Enumerate and zip are siblings. Both take a plain loop and make it richer. Keep them in your toolkit. Let's see the advanced codes. Code these out and open the first advanced example. Alright, now it gets powerful. You can put a loop inside another loop. The inner loop runs completely for every single iteration of the outer loop. Let's see that in action by running the code. Outer loop picks 1. Inner loop runs fully. A, then B. Outer loop picks 2. Inner loop runs fully. Again. And so on. 3 outer values, 2 inner values. 3 times 2. 6 total combinations. This is how you generate every pairing. Fill a grid or walk through a 2D structure. But be careful. The inner loop runs for every outer iteration. 3 and 2 is 6 and it's basic. But 1,000 and 1,000 is a million. Nested loops multiply. This is where slow code comes from, and why you will hear engineers talk about avoiding them when the data gets large. Alright, let's code these out and then open our next example. So, this is the most recognizable feature in all of Python, a list comprehension. Watch me build a list of squares the long way first, as you can see. Let's run this. 4 lines, created an empty list, loop, append, print. It works. Every programmer writes this. But Python offers something tighter. Let's see that one too. First of all, let's code these out and then see the Pythonic way. Save it, then run it again. 1 line, identical output. Read it left to right. Num times num for each num in nums. The loop is still there. It's just folded into a single readable expression. And it's not only shorter. The comprehensions are optimized under the hood. So they often run faster than a regular for loop too. Let's code this beautiful thing out. And then open the next example. Now, there's a filter at the end. For each number, 1 through 10, keep it only if it's even. If it divides by 2 with no remainder. The percent sign is the modulo operator. It gives the remainder. Let's see that in action too. Run it again. 1 line did what would take 5 with a regular loop and an if statement. You'll start seeing this style everywhere in real Python code. It's worth getting comfortable reading it. Let's code these out. This is beautiful as well, but bye-bye. Let's open this one. And it's not just lists. You can build dictionaries the same way. Save the code, then run it. Same syntax, curly braces instead of square ones. And a key value pair instead of a single value. Once you see the pattern, it works everywhere. This is beautiful. And once you get used to using these styles, your work will be easier, definitely. Let's uncode these, save it. Last one, and this connects everything to AI. When a language model generates text, it doesn't produce a whole sentence at once. It generates 1 token, adds it to the sequence, then loops, and generates the next token based on everything so far. Let's run this example. Look at this. The sentence grows 1 token per iteration. That's a loop. Now, this is a simplified version. Real models don't append strings in Python. They predict tokens as numbers, but the shape is exactly this. Here's what the real loop looks like in pseudocode. We will not run this, but I've prepared this example for your imagination. Every response ChatGPT has ever given you came out of a loop shaped exactly like this. Predict a token, append it, loop, repeat, until it decides the response is complete. This is called autoregressive generation. And training is a loop too. The model sees data, makes a prediction, measures how wrong it was, adjusts itself slightly, and then loops again. The same cycle runs billions of times. Loops aren't a beginner topic you move past. They are the heartbeat of every program that has ever run, including the most advanced AI models that we have on Earth right now. 7 videos in this series. You can now store data, organize it, compose it, make decisions about it, and repeat anything as many times as you need. That's the core toolkit. Variables, data structures, conditionals, loops. With just these, you can already write real programs that do real work. Next video, functions. how to take all of this and package into reusable blocks that you can name, call, and build on. If you got something out of this, subscribe. We go one layer deeper every week. You've been listening to Hex 1000, Logic Behind the Code. Signing out.